Okay, so the recording has started. So can everyone see my screen? Right. So semesters to at the end.
Can you hear him? Why?
Then
Just unmute.
okay, so let me create my source files. So we are going to be using main.cpp. Then we're going to have, and I'm gonna call it game space. Or let me just call it game.cpp. Then let me just create my bash file right away. So David.bash. Check if the recording started. So let's just do the bash file right away before we start coding. So start off by switching off our command. So echo off. Gonna compile echo G++, and then you have to change the standard that you're using, which is C++20. Then since you are using modules, you're gonna have -f modules -ts. Then afterwards you specify source files which you want to compile. So currently my source files are in the SRC folder. So you have to navigate to my SRC folder. So SRC, then we're gonna start by compiling game.cpp. Then also going to compile main.cpp. Then at the end, we want to create an executable file, and I want to put it in the bin folder. So I'm gonna navigate to the bin folder. So it's going to be bin, and I'm gonna name my executable file build.exe. Okay, and yeah, this is the line to compile. So as you can see, we start off with the compiler, then write the standard which we are using, which is C++20. Then since we're going to be using modules, we write -f modules -ts. Then we write our source files to compile. You see, my source files are currently under the SRC folder. Then at the end, you create your executable. This is how you create your executable -o. Then you give your executable a name. If you wanted to put in a certain folder, you navigate to that certain folder. Then yeah. Then now we're going to run our code. So to run our code, we're just going to run our executable. So currently my executable is in the bin folder. So I have to navigate to my bin folder. Then I'm just gonna call my executable. Yeah. So during the test, you can edit your source files using Notepad++ or VS Code. But to edit them, I'm just going to use code blocks. So let me open up my files. Okay. Okay, let me open up the other file. So yeah, you are allowed to use. You can edit your source files with using Notepad++ or VS Code. So I'm just using code blocks. So we're going to start with modular programming. So modular programming, like, is an approach where a large program is divided into smaller independent parts called modules. So each module performs a specific task and can be developed, tested, and maintained separately. So in order to keep our code clean, so we're going to create a module. So that module is going to store particular functions. Then in our main.cpp, that's where we're going to export our module. We're going to import our module, and our module will come with all those functionalities that we defined in our module. Yeah. So for example, like a module is like, for example, let's use an example using a bank system. So a banking system may have like separate modules like for login, payments, accounts, and report. So instead of placing everything in one huge file, they created separate modules for logging in, payments, account, and report. So we can have like different modules. So let's say we have a module just for containing the player functionality. Then we have another module just for containing maybe like the world functionalities. Then in our main function, then that's where we import all our modules. Then we use those functionalities in our main.cpp. But for today, we only have one module. So to declare a module, so in our source file, we start by saying module at the top. Then afterwards, you're going to include your header files. So hashtag include IOStream. Then now, after including your header file, that's where you're going to define your module, to declare your module. So to declare your module, you say export, then module, then you give your module a name. So for today's lesson, I'm just going to give my module a name by UJ module. So I'm just going to call it UJ module. Then afterwards, that's where I can say using namespace std. So now, we're going to define a namespace in our module. So my namespace, I'm going to call it UJ space. UJ space. Then this is where we're going to define all our functionalities, our functions, to that we want to use. So for example purposes, I'm going to create one function here. So I'm going to make a void function. I'm going to call it display. Then this function is just going to display hello random. That's it. So if I want my display function to be part of this module, so I need to put my display function inside my module. So how do we do that? So in front of this in front of the function declaration, you say export. Say export. Then you can have multiple functions. So let's say this function is display to. Let me say. Let me call it greet. Then I'm just gonna say hello guys. So we have our two functions there. So our functions are part of our module. So now when we go to the main.cpp, so guys, this order matters. So you first have to say module, then include your header files or header libraries. Then afterwards, that's when you can declare your module. Then afterwards, that's when you can say using namespace std. So let's say you put this thing before the module declaration. This is going to cause an error. So the order on how you do these things, it matters. Otherwise, you're going to end up with an error. So anyways, in our main.cpp, we start by including our header files. Then afterwards, that's when we import our module. So currently we have our module is called uj module. So just say import, then you give the name of the module which you want to import. So our module is uj module. Then now you can define your namespaces. So using namespace std, then using namespace. So here I'm gonna use my user-defined namespaces uj space. Then I'm gonna create my main function. So int main return 0. Then so since we imported our module, I'm just going to call my functions from my module. So I'm gonna call my display function. Display. So now let's run this and test it out. So this is my bash file. I'm gonna run it using my bash file. So compiling. Hello Brandon. Oh, let me pause at the end. Pause. And yeah, this is how it works. So let's say over here, I didn't grid is not part of my, let's say grid is not part of my module. Then let's say I try to call my grid function here. So you see this will give me an error. As you can see, so grid was not declared in this scope. So I cannot use grid because it's not part of the module. So in order for me to use this function, I have to export it. So if you compile our code now, you should be able to see the grid function execution. As you can see, hello guys. All right. So here you're going to have a lot of functions, and each function which you want it to go with your module, you have to explicitly say export before each function declaration. But then in order to avoid that, you can just do this once. So you can just say export, then so you can just say export, then you open your export scope. So everything between curly brackets, we call it a scope. So in the scope of this export, then that's where you can write all your functions inside. So automatically they will be exported. So to avoid explicitly writing export on each and every function, we can just do this, which is much faster. So if you do it like that, yeah, you'll be able to include all your functions in one module at the same time. Yeah. So yeah, this is modular programming. So is there any question on this before we head over to something else? Yeah, you can ask. Uh, I don't know how to pronounce your name. Adivavo. Yeah, you can ask your question. You can type or can. Oh, you're saying, can you please repeat the calling part? Yeah. So as you can see, you defined your function here. So in your main.cpp, you just have to import your module, then define your namespace here using namespace uj space. So this is your user defined namespace. You just have to call them. Then to use your function. So currently this is a void function. So to use your function, you just call it. So currently we have a display function and a build function. So to use a function, you just call them like this, as normal, as if they exist. Yes, they exist. They come from they come with your UJ module. So this is how you call them. I'm not sure if that's what you wanted me to talk about. Yeah, you can unmute and say your question, just to be faster. Oh, thank you. That's what I was asking. Okay. So let's continue. So now let's head over to command line arguments. So up until this point, we have been getting our user, or not up until this point, up until a particular point in computer science 1A, we only accepting user inputs from the user via the input stream. So by the input stream, I'm talking about CE. So let's say, for example, required a name and an age from our user. So int age. So if we wanted this input from the user using the input stream, this is how we will do it. Let me say enter name and CE age. So this is how we did it. So let me display something over here. So yeah, normally this is how we would get an input from a user. So enter name, let's say Brandon, age, let's say maybe Brandon is 40. And yeah, this is how normally we would obtain an input from the user. So using the input stream, we can get any input. We can get an input of any data type. So now, with a command line argument, uh, when we get an input from the command line argument, it means like we're getting an input from the command prompt. So let's say I want to run my code. So let's say I want to compile my code. Okay. So let's say I want to compile my code. I was going to say, you see this thing, this is the command prompt. So when we talk about command line arguments, when we say these inputs are from the command line arguments, we mean that from this command prompt. So this is how we're going to get a input from our users. So let's say let me compile my code. Build enter name. So yeah, let's so at the moment I'm only getting the inputs from my input stream. So if I wanted to pass inputs from the command prompt, cmd, this is where we're going to pass our command line arguments. So in order to accept inputs using via the command line argument, so we have to overload our main function. So this is how we overload our main function. So we're going to have int argc and char pointer and argv. So we command line arguments. So command line arguments is like you have like a list of inputs from the command line argument. So argc is like an array of inputs from CMD. So this is an array of command line arguments. This is an array of arguments. Then we also have argc. Argc represents the size of this array. Yeah. Can I ask you a question? Can you please repeat the part? Go back a little. Oh, so right now we are on a command line arguments. So normally we accepted user inputs using the what's this the input stream. So right now we're no longer going to obtain user inputs via the input stream. We're just going to pass our inputs to the command prompt. So in order to be able to do that, we need to overload our main function. So we overload our main function with the size and an array. So we have argv. Argv is an array of all those inputs, and argc is the size of this array of inputs. Inputs from where? The command prompt. All right. So at the beginning, the size of our array is always going to be 1. If we don't, can we also say int main? Yeah, you can also do that. You can also say char pointer, and you can also do it like that. But you can also do it like that. But I'm just going to use char pointer argv. Okay. So remember how you used to define an array, something like numbers. Then you do this, then you will say this is equals to 1, or let me say 21, 22, 23. So this is one way of defining an array. So you say int, then your name of your array, then immediately you define the elements in your array. So the size of this array will depend on how many elements you pass here. So at the moment we have three elements. So the size of my array numbers is going to be 3. Okay. So same as this array of arguments. So the size of this array is going to be defined by how many elements or inputs from CMD you pass. Okay. So by then automatically every time ARGC is always going to be 1. It's always going to be 1 because every time when you compile your code, one element is defined in this array of arguments ARGV, which is the name of the program. So if right now I display the size of my let's display ARGC. So this is how we're going to display it. So let me run this. So as you can see, the size, even if you don't pass anything from the command prompt, the size is going to be 1. It's always going to be 1. That's because already there's an element which is passed automatically to this array of arguments. This is the name of the program. So let's display it here. So let's say argv at index 0. So if we display that, let's compile our code and run. We will see here, we will see the name of our program. So this is the name of our program. So now let's say I want to pass something from my command line arguments. I want to pass something. So let's say I want to pass my name and my age. Let's say I'm 40. So as you can see, you're only passing 2 things. But then as I said, the name of the program is passed automatically. So if you are passing 2 things, just know that the size of the command line argument is going to be the number of the things you are passing plus 1. So that plus 1 represents the name of the program. So okay, this is how we pass. This is how we pass our argument. So now, if I run this now, you're going to see that the size ARGC is going to be 3, but you only pass 2 things. So the other one is the name of the program. So remember with cin, you can store, you can get anything, any variable of any data type using cin, but then with command line arguments, you can only get inputs as strings only. So by then, okay, before we do that, let's display. Let me say program name. Then here, let me say name. So before we do anything, let's try to display these things that I'm passing here. So this is going to be at argv1 and end line. Then let's see out my age. So I remember today we're just doing basic stuff. To end line. So let's display that. So yeah, you can see the size is 3, the name of the program and the name and my age, which I passed via the command prompt. So even if I pass something here, so you know with arrays, if you are passing three things, if you want to access them, let's say, let me do something here. Let me say index 0, 1, 2, then values. So at index 1, we have the name of the program, and the name of the program, and index 2, we have my name, Brendan, and at index 2, we have 40. So yeah, this is how it works. You can see that we're passing three elements, but then if you want to access these elements, we use an index. An index starts from 0. So if an element, if you have three elements and the if you have three elements and the index starts from 0, it means the last index is going to be 2. So you're going to have the first index as 0, the second one as 1, and the third one as 2. So you still have three elements, but then in order to access those elements, you use an index. So the index starts from 0. So yeah. Okay. So as I was saying, so everything which you are passing here, uh, we get them. We get these arguments as strings. So remember, with Cin, if maybe you had an integer age, you'll be able to do this. And then with command line arguments, this is not possible. You can only obtain strings from the command line arguments. So let's say for example we want to store these values. So let me declare them. So string program name is going to be argv at index 0, string name, which is going to be argv1 string, then finally age is going to be argv at 2. Then let's say, then here instead of doing this, I'm just gonna use my variable name. So here I'm storing my inputs from the command line. I'm storing them in my variables. So the first one I'm storing it in the variable name, and the second one I'm storing it in the variable age. So if I compile this will compile on successfully without any errors. So now for age, so let's say we want to store age as a number, because the age is a number. So let's say we try to do this. We try to set age as a number. So if I try to compile this now, I'm going to get an error. There is my error. Invalid conversion from char pointer to integer. So as I said, these things come from the command prompt as strings. So this thing will crash because you are trying to store a string. You're trying to store a string inside of an integer. That's wrong. So now, but then what if I want to use this age as a number somewhere? Remember from our command prompt, we're going to store things like rows. So if I want to store something as an integer, it means I must get this thing and convert it from a string to an integer. So now we're going to define a function that converts strings to integers. So So the main reason why we're converting these things from strings to integers, let's say maybe from our command prompt, let's say we're passing the number of rows for our 2D array. Let me cancel this. Let's say we're also accepting the number of rows from the command line arguments. So let me make this thing back to string. So let's say we had rows, so IGV at index 3. So let's say we're also getting the number of rows from the command prompt. Okay, those are my rows there. So let's say these are the number of rows. If I try to create a for loop, remember in our arrays, maybe you want to loop through your array. So then you try to say int r is equals to 0, then r is less than rows and r plus plus. See out r. Let's say you try to do this thing. So you see if I try to compile my code, I'm going to get an error, as you can see. So the reason why we got an error here, this is because a for loop is expecting a number here, and a string is not a number. An integer, the only numbers we have from C++ are integers. So here we're expecting an integer variable, and you are saying rows, but rows is a string. So you'll get an error, because remember, with a for loop, we're counting from, let's say here we say 0. So we're counting from 0 up until, let me say equals to, up until the number rows. But then rows is not a number. Rows is it's a string. So meaning we won't be able to allocate memory for array. So let's say we had an array 1D, for example, then you try to say what new 1D is equals to new int, then you try to do this. This is also going to give you an error. That's because rows is not a number. So we are expecting a number, but then you are giving us a string. So the compiler will complain. Rows is not a number. So that's why we need to convert these things to integers. That's why it's important for you to convert them. So we're going to create a function here to convert strings to integers. So a function will return an integer. I'm gonna call it convert con to int. I'm gonna call it that. Then we're going to accept a string. We're going to accept a number as a string. So I'm gonna call this string num. Then in here we're going to declare an int num. Then at the end of the function we're going to return an int number. So we have to convert this thing to an integer. How do we do that? So in order to convert something to an integer, we're going to use a string stream. So this is like a data type. So string stream, we're going to call it SS. So string stream SS accept a string. So we're going to accept a string number. But then string stream is from the header library stream. So we need to include that header library. So as string. So So in order to use stream, you have to include this library first, which is stream. So stream, you declare it. You say stream. This is the data type, string stream. Then you give it a name. Normally we call it ss. Then you pass a string. So for our example, we're going to pass str number. So you pass a string. So now to do the conversion from string to integer, we say ss, then you use these operators, then int num. So this is where the conversion happens. So when we declare ss, we give it a string. So what this code does is that it takes that string and tries to put it inside this variable int num, which is of data type int. So this is where the conversion takes place. So it's going to try to take that string and put it inside this variable int num. So it's possible that this conversion fails. So if that conversion fails, we need to check if that conversion fails or not. So we're going to create an if statement here. So to check if this conversion has been successful or not, we're going to say ss.fail. Going to check. So we're going to say ff.fail. So and if the conversion has failed, we want to output an error message. So let's say failed to convert a string num to an integer. Then you want to exit your program. So to exit your program, you can exit with any error code. So I'm going to exit my program with an error code -1. So yeah, obviously if the conversion is successful, we're going to return our int number. So in order to use exit, I have to include my cstdlib library, cstdlib. So yeah, but if you come to this side, let me bring back these things. Let me cancel out this one. So if you come this side, for our age, so we're going to declare age and rows as integers. Then here, we're going to pass our input to our convert int function, which is going to convert these inputs to integers. Okay, so now if we run our code, we should see we will no longer get that error. As you can see, so this is the for loop I did at the end. This is this for loop. So you see now we no longer have an error because rows is a number, so we no longer have an error. So now because we converted those things to integers before we stored them, so that's the main reason why we convert these things to integers. So yeah, this is command line arguments. Any question on this, on command line arguments?
So,
Yeah.
what does if you wanna convert, don't you also use AGTOI or AGOI? What is that about?
Yeah, you can also use that function to convert your strings to integers instead of creating your own function. But I think
Okay.
just to create a function to convert strings to integers gives you marks in the test.
Bro.
So you might want to create your own function instead of using that defined function.
Okay.
Oh, yeah. I saw a hand raised. Adi Verbo, you still want to ask your question? You still have a question or you're sorted? Okay, doesn't seem like they still want to ask. Oh, okay.
It's Ntwanano.
Oh, okay.
I wanna ask, why did you use the thing you converted right with the function, and then you changed the int it was string rows, and then you change it to int rows. Why?
I changed what you say. I changed this thing from string rows to int rows. This is because I'm using my function convert int. So convert int returns integers.
Okay.
So that's why my rows have to be of data type int.
Oh,
I'm
okay.
not sure if you understand me.
We declare our.
I don't get it.
So okay, let's do this. Let's say so you see our function here, which we defined. Our function returns integers. We pass a string, and that string is going to be converted to an integer and it's going to be returned. So if we go to our main, we see that we are calling our function here. Our function accepts a string. It accepts a string, then it's going to return an integer. So obviously you can't store an integer inside of a string. That's why I changed this string to an integer. Yeah.
Okay, I get it. Thank you. Thank you.
Sure. Any other question? Konke, nonke.
Yes, so I wanted to ask if so it's not like required to create a text file. We can just use a batch file in the exam to pass our command line arguments.
Yeah, there's no if you are using VPL, then you are required to create that input text file. But then if you're not going to use VPL, there's no need to create a text file because you just pass your command line arguments via your batch file. Depends on what you are using.
Oh, can you please repeat that again?
So if you are using VPL, so to pass arguments via VPL, so to pass arguments in VPL, you need to create that input.txt file. But then if you're not using VPL, you're just using Notepad++, there's no need to create input.txt. You can pass your arguments via the batch file. Do you get it? You create the text file only if you're using VPL. Is that clear? Is Gong still here? Okay. If there's no other question, I think we can continue. So let's move on to operations. All right, let's head on to. Want to ask a question?
I have a question. Yeah. Can you please go back to the game.cpp file so I can see how you did the instant part? Okay, thank you.
Okay, so remember, I'm going to send you this code afterward in the recording. So. But if you have a question, you have to ask it now, so you can clear out everything, any misunderstandings from now. So yeah, to convert, you need a string stream variable. In order to use that data variable, you need to include this header library stream. So I think these are. So you create your string stream variable, then you give it a name. Normally we call it SS. Then you pass a string. then here you try to convert. So you say SS, then you use this. These ones, we call them extraction operators. So I'm not sure what these ones are called. I think something like, let's say, I'm not sure what those ones are called, but then you use these ones. So this is where your conversion happens. So this conversion is either going to be successful or is going to fail. So here you check if that conversion fails or not. So let's say here from my, so let's say here, instead of saying 20, then we type it alphanumeric, then we say 20. So this alphanumeric 20, it's not possible to convert it to an integer. So if we try to run our code, we're going to get an error. As you can see, so failed to convert 20 to an integer. So that's why we create that if statement. So yeah. Anyway, let's move on to, I see Adi Vervo is typing off. Can you please show us how to create the input.txt? Because apparently we have to use a VPL. Now, it's not a must for you to use VPL. You use anything you want. It's not a must. So obviously, if you are using VPL, you have to add that file. Ish, I don't know. I don't feel that I don't have access to VPL because I'm an assistant marker, so VPL, I don't have access to VPL. Otherwise, I was going to show you how you do it, how you add that txt file. That is, you add it the same way you add a file in VPL. How you add main.cpp. That's how you add it the same way. So you say add, I think there's a plus button. You say, you click that button, then you say, they will say name your folder, name your file, then you say it's input.txt. The same way you would do it when you are creating a main.cpp or your source folder for your module. You do it the same way. Okay, so but anyway, let's move on to enumeration. So at some point in your code, you might want to use constants. Maybe like for error codes, maybe you may want to use constants. So let's say you have const int success, then const if you are creating a constant, you need to define its value. Then let's say you have, let's have an error code here for I'm gonna call it error ERGV. There's an error code for if let's say we are trying to convert a string to an integer and that conversion fails, again we're going to exit our program. So here, let me store this error code in this error to underscore ARGV. I'm gonna store it here as -1. Then, so here instead of writing -1 explicitly, I can just use my error code. I can just use my error code, which is a constant. Then in my main.cpp, instead of exiting my code with, I can just use success. Instead of explicitly writing 0 there, I can just call my variable success. So yeah, my program will run on as usual. So let's say, so now, so these let's say these are the constants which you want to create. So now, instead of creating these constants explicitly like this one by one, there is a way to just create them like in a bundle. So then in order to do that, you're going to use enumeration. So an enumeration is a user-defined data type that consists of a set of named constant values. So in order to avoid creating these constants one by one, you can just put them together. You can just put them together and create them together like all at once at the same time using enumerations. So enumeration is like a list of constant variables that have constant values. So to define your enumeration, so you say enum, then you give it a name. So I'm gonna call it error codes. So my enumeration error codes is just going to store some error codes. So first of all, I'm gonna have success. Then I'm also going to have error hash argv. So yeah, so instead of creating them one by one, you can just do them like this. So and with enums, the first one you place here automatically is going to have a value of 0, and the second one is going to have a value of 1, and it continues in that order. So let's say you have another one here. Automatically this one is going to have a value of 2. So the first one is going to automatically have a value of 0, and the second one is going to have a value of 1. So the values of these ones depends on whatever value this one is. So let me do this. So by using enumeration and just bundles these constants in a data type. So like if enumeration is like you're creating your data type, and that data type consists of a list of constant variables. So yeah, instead of like creating them one by one. So let's say here I want my error argv to be equals to -1. So I'm gonna do this. I'm gonna put it before success. Then I'm gonna equate it to -1. Then automatically success is going to be 0. So if you change this thing, and maybe you say, if maybe you said this thing was 2, automatically the following variables are going to continue from this number. So if this is 2, automatically this is going to be 1. So if you said this is -1, this automatically is going to be 0. Like it follows an ascending order. But then if you leave it like that, automatically the first one is going to be 0, the second one is going to be 1, in an ascending order. So let's just give this one, let's just place this one as -1. Then yeah, so if I run this now, so everything will just continue on as normal. So yeah, so instead of creating your constant variables one by one, you can just create them put them in an enumeration. So this is how enumeration works. So it's like it's a user-defined data type that consists of a set of named constant values. All right. Is there any question on that? So normally for enumeration, you want to store your error codes normally, or you can store maybe like your characters or something like that. So it's just a list. It's just a list of named constant values. Integers. Any question? Can you please any question on enumeration? That's basically it on enumerations. Okay, if there is no question, yeah.
Can you see me? Do we have to put the enumerations inside the export thingy?
Yeah, because if you don't put them in the export, you won't be able to use them anywhere where you're importing your module. So let's try that initially. So if it compiles, so you see there's an error here. It doesn't know what success is. So it's a must for you to put them inside your export.
Eh?
It's a must.
Okay.
Any other question? So you're all fine with enumerations. So let's head over to. Are you talking to me or?
Oh, sorry, my bad.
So since there's no question from enumerations, let's continue. So we did modules and namespaces, command line arguments, did enumerations. Let's do structures. Let's do 2D arrays. I'm gonna cancel out all of these. This. So here I'm going to pass from the command line argument. I'm going to pass rows and columns. Just pass rows and columns. So I'm just gonna pass rows and columns. So now we're going to work with 2D arrays. So I'm not sure how deep into details I must get in 2D arrays into pointers to be exact. So, but let's just do it. Let me use Paint. So I want to draw some things to illustrate how pointers work. Should I go deep into details with pointers, or can just give you an overview? I don't want to do something which you already understand. Okay, but let's just do it. So we're going to start with okay. So already you know how to use what's this, to use arrays. You already know how arrays work. So now with pointers, so let's create a one pointer here. Maybe for example, let's call it 1D. So remember a pointer is like it's something that points. It's like an address. So a pointer points to a variable. So okay, let me draw something here. Use this. So I'm gonna draw something here. So this is my pointer. So pointers point let's do something like this. All right. So a pointer is like an address. So that an address points to a house, and in that house, there's a person inside. Let's draw a statement, something like that. So what a pointer does, a pointer points to a variable, and that variable has an element inside. So it's like an address. It's like an address of a house. So that address gives you a house, and inside that house, there's a person inside. This is like how you can think of pointers as. So you can think of pointers as like that. So pointer is like an address, and that address points to a house, and that house inside has a person inside. Okay. So the way which we are going to use pointers is that we're going to use our pointer to point to a list of variables. So let me add some few things here. Can I let me do this. Let me do this. Let me place some multiple variables here. So yeah, the way which we are going to use pointers is that we're going to make our pointers point to some list of variables, and those variables are going to contain elements inside. So this is like in terms of addresses. So yeah, this is like an address, and that address points to a bunch of houses, and in those houses we have people inside. So let's say this pointer points to Polokwane, for example. This pointer points to Polokwane. Then in Polokwane, there are a bunch of houses. So obviously, if you want to access a specific house, you're going to use a sub address. So a sub address is known as an index. So let's say so an index from index 0 to 1. So yeah, we have an address here. It points to Polokwane. But then when we get to Polokwane, we're going to find multiple houses in Polokwane. And let's say specifically you want this house. So to access this house, we're going to use a sub address, which is known as an index. So this is how pointers work. So now let's see how that works in code. So you have to instantiate your pointer in order to use it. So to do that, so instantiating is allocating memory. So when we use the new keyword, we say that we are instantiating. So we're going to say new. So let's say the variable that we want our pointer to point to, we want it to store an integer. So here we're going to say integer. The reason why we are saying int is because we want so this is an address. So we want the houses that this address is pointing to store integers inside, to store people inside. So that's why here we say int. Then here we're going to give the size of our houses or of our variables. So currently we have six houses here. So we're going to say 6. So what this line of code does, so that line of code does is that it points to 6 variables, and those 6 variables must contain integers inside. They're going to contain integers inside. This is like an address. An address points to houses, and those houses contains people inside, a human inside. So yeah, so obviously for code, those houses, those variables are going to store elements inside, and those elements are going to be of data type integers. So now let's say we want to access. So yeah, we have our pointer here, and our pointer points to this thing. So for example, our pointers are going to store numbers inside. So okay, let's say we want to access a particular house. So as I said, we're going to use an index. So let's say we want to see whatever that's inside. Maybe let's say this variable. We want to access whatever element that's inside this variable, meaning we want to see the human which is inside this house. So this is currently house number 3. So this is house number 4. But then to access house number 4, we use an index. So that index is going to be 3, because indexes start from 0 to 5. So if we want to access house number 4, we use an index of 3. So here we're going to say 1D, then we say 3. Then this is how we're going to access a house or a variable. This is how we're going to access a variable inside an array. So inside of this array, I get this pointer points to an array, to a list of variables, and then we want to access one variable from that list of variables. So this is how we're going to do it. So remember, with pointers, you're allocating memory to your disk. So every time you say you type new, you have that new has to go with its own delete. So yeah, we have to always delete our pointers. So here I'm just gonna delete my pointer. So so as you can see, this pointer points to multiple variables, but we're not deleting these variables one by one. We're just deleting the whole pointer. We're not deleting this. So automatically, when you delete the pointer, these variables, all of them are going to be lost. So we only delete pointers. We don't delete these things here, the variables which the pointers are pointing to. So now if we run our thingy, we're going to see the element inside house 3. It's house number 4, but then the index is 3. Okay, failed to convert Brandon to an integer. Oh, let me cancel. Let me pass rows and columns here, and let's run. So you can see the element in house number 3 was initialized to 0. So let me use a for loop to access all the elements in that array. So from int r goes to 0, r is less than, so the size of my array is 6, then r plus plus. So I'm just going to display all the elements in those variables. So this is 1D at index r, and I'm gonna create a space. So yeah, if I run this now, you'll be able to see all the elements in my, so everything is initialized to 0. So actually this thing can be initialized to any number, to any random number, but in this case everything was initialized to zeros. So obviously we can initialize them ourselves. So let's initialize everything to, and let's say this is let's say this is equals to r times 2. Okay, then let's display the thing is here. So yeah, if I run my code, we should be able to see something like 0. There's an error somewhere there. So int r is less than 6. So for int r is equals to 0, r is less than 6, r plus plus, then we say r. Okay. Let me cancel this. I don't know what's that error about. Yeah. So you can see from our element, we initialize everything from 0, 2, 4, 6, 8, 10. So this is how we access, and this is how we access these elements in our array. So this is a 1D pointer. So any question on a 1D pointer. So this is how we allocated memory for our pointer. We initialized, we displayed, then we deallocated, we deleted our pointer. Any question before we move on to 2D arrays? All right. Okay. Adjectival. I wonder if I'm pronouncing your name properly.
Like what?
Okay, sir, which numbers does it store? Which number does the point like this array store? And where does
So
it start?
you see from here, I said 1D at R. You see, I get my loop, my R runs from 0 to 5. So at R, I'm storing R times 2. So, okay, let's just store everything as R. Going to see 0, 1, 2, 3, 4. So I initialize those things here, but I just say times 2. So this is where I initialized. So if you don't do the initialization yourself, everything is going to be initialized in that array. Every element, every variable in that array is going to be initialized to some random number. In our case, everything was initialized to zeros. So yeah. So this is where I changed everything. This is where I changed all those elements. So remember R starts as 0. So 0 at index 0, place 0 times 2. That's going to be 0. Then at R is equals to 1. 1 at 1D index 1, assign it to 1 times 2. That's going to be stored as 2. So that's what I did there. That's how the initialization went on. I'm not sure if that answers your question. Okay. So let's head over to 2D arrays. Let me copy out this. Okay. Let's head over to so this is going to be in pointer. I'm gonna call it G. Okay. this creates this pointer. So now we want to allocate memory for our pointer. So we're going to say 2D is equals to new int pointer and give it a size of rows. So remember, so you notice that here we say int pointer. So remember, int pointer, it's a pointer. Remember last time we were pointing to an array of integers. That's why we only had, let me write some comments here. Int pointer 1D goes to new int rows. So here with 1D arrays, we only had new int rows. So this just meant this pointer is going to point to an array of integers. That's why we only wrote int. But in this one, our array is not going to point to an array of integers. It's going to point to an array of pointers. So when you only say int, it's only going to point to an array of integers. But then when you say int pointer, it's going to point to an array of pointers. So it's like an address pointing to another list of addresses. So in this demonstration, this is how it's going to be like. This is what's going to happen. Let me point them here. So you're going to have something like this. But then these things are not going to be variables. These are going to be pointers. Let's just do this. A little bit messy. So this pointer named 2D is going to point to an array of pointers, not an array of integers. Does everyone get that point? So this 2D is going to point to an array of integers, to an array of pointers. So the size of that array is rows. So let's say rows is 5. So it's going to point to 5 pointers. So this is what this line of code does. Then now, what we're going to do is that we're going to make each pointer point to an array of integers. So again, we have a pointer, then that pointer points to an array of pointers. So each pointer in this array of pointers is going to now point to its own array of integers. So I'm going to do something like this. So I'm not sure I can this. So yeah, as you can see from our illustration here, so we're going to have a pointer, and that pointer is going to first point to an array of pointers. It's going to first point to an array of pointers. And in this array of pointers, each pointer is going to point to an array of integers. So these things are like the 1D arrays we just created. So this is like a 1D array, a pointer pointing to an array of integers, a pointer pointing to an array of integers. Just that before that we have the first array, you have the first pointer which points to an array of pointers, and each pointer in this array of pointers is going to point to its own array of integers. Pointer pointing to an array of pointers. Each pointer in that array of pointers is going to point to its own array of integers. Does everybody understand that? So, okay, in code. So at the moment, we just have an array of pointers. These pointers. So in that example that I made about addresses, so let's say this pointer points to Polokwane, but then in Polokwane we have different addresses. So let's say this is in Polokwane, this is Bochum, for example. Actually, let me use names familiar to you. Let's say in Polokwane, there's a place called London. There's a place called, this is a bunch of places. So this is Polokwane, and in Polokwane we have different places, and each place in it, there are houses in that place. So this is Polokwane, and Polokwane will point to these addresses. Let's say this is Bochum, for example. So Bochum will have a list of houses inside, and in each house there's going to be a human inside. So think of it think of it like that. So yeah, it's like a province, and a province points to, let's say this is a country, and these are a country points to some provinces. In each province you have houses, and in every house there's a human inside. So think of it as that. So here, so at this point, we just have our 2D, our pointer pointing to an array of pointers. So now we want every pointer in that array of pointers to point to an array of integers. So we're going to loop through these pointers. So for int r is equals to 0, and r is less than rows, r plus plus. So here we're accessing every pointer. So this is pointer at index r. So these pointers. So we want each pointer to now point to an array of integers. So this is going to be pointer at index r is equals to new int. Then so we're going to point to an array of integers of the size columns. So let me use my numbers here. So let's say this is 5, 5. So yeah, we have 5 pointers here, and each pointer is now going to point to an array of integers size 5. So this is what happened. This is what is happening here. Then remember I said every pointer that you create, you have to delete it. So we have this pointer here, then we have these pointers here. Yeah, we have to use pointers, it's a must. Then we have these pointers here. So in the allocation, you have to delete all these pointers. You have to delete these pointers, then you have to delete this main pointer. So this is how our deallocation go, right? So yeah, we're going to loop through our array of pointers first. So for loop int r is equals to 0, r is less than 5, then R++. Then we're going to delete every pointer in our array of pointers. So this is 2D index R. Then afterwards, after deleting these pointers, we're now going to delete the main pointer. So after this while loop, we're going to delete the main pointer. So this is going to be delete 2D. Yeah. So now let's say you want to access these values. Let's say you want to access these elements. You're going to access them like this. So first of all, you're going to access the pointer. Then from the pointer, you're going to access the specific variable. Again, each pointer points to an array of integers. So you're going to first allocate the pointer. Then in that pointer, you're going to go through the list of integer variables inside it that this pointer is pointing to. So you need two indexes. So this is the index of this pointer, and this pointer has an array of integers. So you need to also have an index to access those variables in that array of integers. So we're going to first loop through the array of pointers. So R is less than 5, and R++. So this R represents the index of a pointer. Then now at each pointer, we have an array of integers. So we need another index to access the variables in that array of integers. So we're going to have another for loop. So int c is equals to 0, c is less than 5, then c++. So now let's just see out whatever that's stored in our arrays. So 2D at R net C is less than, or let's space there, C out and fine. So you see I haven't initialized anything yet. So if we display those variables, they're just going to be initialized to some random values. Might be 0, might be any other random value. Okay, it's running. So as you can see, this is the array. So let me put this thing side by side. So you see from here, this pointer pointed to this array. This is the array. Then this second pointer at index 1 pointed to this array. This is the pointer. So it's like when you're creating that for that nested for loop, you first go to the pointer, then you go inside the pointer, then access every element in that array which this pointer is pointing to. So this is what's happening. Any question? I didn't initialize anything, so automatically everything was initialized to zeros. Can be initialized to some random numbers. Any question? All right. Yeah, I hope that's clear. I hope that's clear. This is as deep as I can go. So yeah, each pointer points to its own array of pointers. So this is pointer 1, pointer 2, pointer 3, pointer 4, pointer 5. So pointer 1 points to this array of integers. And yeah. So obviously, yeah, if you want to, so yeah, if you want to initialize it, you can initialize it. So So let's initialize only. Let's only initialize this one, this first value. So to do that, go to say 2D. So we first specify the index of the pointer. So we're going to go to the first pointer. So its index is pointer, it's index 0. So we're going to say index 0. Then now want to access the first element in this array, which this pointer 0 is pointing to. So the first element has an index of 0. Here we're going to specify that. Then let's say this is equals to 1, for example purposes. So now if we run our code again, we will see that that first element is going to have a value of 1. We can see. So remember I said these other ones are going to be initialized to some random numbers. Can be 0, can be some random numbers. That's why you see these values. Last time they were just initialized to zeros. You see these ones were initialized to zeros, but these ones were initialized to some random numbers. But then the main focus is this one. So the first element, which we just, so yeah, we just initialize the first element as 1. So yeah, that's the point. So obviously you can also initialize everything all at once. Let's initialize everything to 1. If you use that for loop. So if I run my code now, only going to see ones in my 2D array, as you can see. So yeah, any question? Is this understood? Okay. So now, let's say you have, so I got it. These are arrays of integers. So let's say you don't want to agree these are that array contains integers inside, but then you don't want to display them. You don't want to display those integers, but you want to display the characters instead. So the way I display characters is that I create another array of characters. So I will call this array characters. This is an array of characters. Then I specify the elements inside this array of characters. So the first element I'm gonna give it a dot, and the second element I'm gonna give it a p, and the other element I'm gonna let's say it's a hashtag. So I have an array of characters here. So my array of characters, it's a list of characters. So at index 0, I stored a dot, and at index 1, I stored a p. So obviously, if I want to access these elements, and as always, I'm gonna use an index. So I'm gonna say characters. So let's say I want to access this dot. I'm gonna give it 0. End line. So if I run this now, we're going to see our dot at the top. This is our dot. So let me display all the elements. Surely, let me display the element, and let me create a space in between characters at index 1, space, and characters at index 2, space. Let's just display all of them. So yeah, we run that again. This block. So you see the dot at index 0, you see the P at index 1, you see the hashtag at index 2. So yeah, so this is my array of characters. So now I'm going to use this array of characters here. So remember, this is how we access these elements in my 2D array. So obviously at the moment, everything is initialized to 1. Okay. Everything at the moment is initialized to 1. So that's what I'm doing. So and I'm displaying the values. So let's say instead of displaying those ones, I want to display them as characters. So I'm going to use my array of characters. So remember, this thing returns whatever that's stored at index RC. This you see, you have to make sure you understand this. So this returns whatever that's stored at index RC. At the moment, everything is just 1. Everything is initialized to 1. So now I'm gonna take this thing as an index. I'm gonna take this thing and put it as an index to my array of characters. So yeah, I got this in my array of characters. So my array of characters at index 0, we have a dot. At index 1, we have a P. At index 2, we have a hashtag. Then for my 2D array, at the moment, everything is initialized to 1s. So now, if I pass this thing as an index to my array of characters, these 2D at R and C will just return whatever that's dot at R and C. This thing will become an index to my array of characters. So if this thing is going to return 1, it means that one is going to that one is going to be an index. So it's going to be characters at index 1. Then characters at index 1, we see that we stored a P. So it means instead of displaying 1, it's going to be a P instead. So if I run this now, we see you're going to see some bunch of P's. So let's initialize everything to zeros. We initialize everything to zeros. It means 2D at R and C, it will return 0. So everything this thing is going to return a 0, and that 0 is going to be an index to my array of characters. An index of 0 in the array of characters is a dot. As you can see, it's a dot. So if I run this now, only going to see dots there. As you can see, is there anyone who don't understand what's happening here, especially here? So, but then this returns whatever that's stored in my 2D array at R and C. So let's say at R and C, a 1 is stored. So it means this thing will return that 1, and that 1 is going to become an index to my array of characters. But at index 1 in my array of characters, is stored, a P is stored. So a P is going to be returned here. So let's say 2D at R and C returns a 0. That 0 is going to become an index to my array of characters. And in my array of characters at index 0, we have a dot. So this overall is going to return dot. Is there anyone who don't understand this? Who doesn't understand this? Anyone? But yeah, this is how we display those characters instead of those integer values. That's how we do it. Any question? So this is a matter of practicing. Any question? So you all understand this. Okay. Seems like there's no question. So I'm gonna cancel everything since there's no question. So this is a matter of practicing. So are you guys sure there's no question? Can I get a thumbs up just to indicate that you understand? No, just to show me that you understand. Right. Thank you, Pendulo. Yes, Pendulo. The rest. Okay. No risk. Oh, Conke. Okay, I did. Oh, thank you. So yeah, so the last thing we're supposed to do is structures. So, I'm gonna be fast. Technically, our time ended. So, so raise up your hand. Thumbs up. Then let's do what's this thing? Let's the structures. So gonna let's have some. Let's declare some functions here. Function to allocate memory. So which we're gonna pass a size which is rows and columns. Just push. It's fine. This is this is what I just did now. So I'm just inside. So I will need these functions to explain structures. R Okay, this is my function to allocate memory. Let me create another function to deallocate display. This is a function to display 2D. But the reason why I'm creating this thing because I want to talk about structures. I want to create my array of characters. Okay, what I'm doing now is the same thing I was doing CP. So put in functions. Okay, also let me create a function to do Yeah, so nothing new here. This is exactly what we just did. I just put it inside my module. So we have a function to allocate memory, which passes a 2D array, the rows and the columns. Then we allocate memory for a 2D array, blah blah blah. Then here I initialize everything to zeros. Then we have a function to deallocate memory. We only pass the 2D array and the number of rows, the size of the array of pointers. And yeah, we just deallocate. Then we have a display function. We pass in system. Still, we pass our 2D array, the rows and the columns. So here, if I were to create a 2D array, so 2D, then instead of then I'm gonna call my allocate memory function. Then I'm just gonna pass my 2D array, which is 2D. Then I'm gonna pass the rows, which I got from my command line arguments, and the columns, which I got from my command line argument. And I'm gonna call my display function, which I pass my 2D, then my 2D array, the rows and the columns. Then at the end, I'm gonna deallocate memory. So to deallocate memory, I only passed the 2D array and the column. My 2D array. Display is my 2D array. Characters C fine. Paper. This should work, but I think there's an error somewhere which I can't see. Can it spot the error? Not sure. Yeah, okay.
So there by the module interface file, I think we should display the world first before deallocating it. I don't know if that will work.
It display. Oh, this display. I did display first. Click on some uh, See here, it's a constant or something. So let's declare this array of characters as a constant, and let's see that's gonna do the trick. Okay, still something happening, which I can't seem to be able to spot. Hello. So my array of characters. Page memory function. Pointer comes. Then say scores to pointer. Then for scores to plus plus. Then comes. That's okay. Then C is equals to C is less than comes. This is 2020. So allocating, there is no error there. Then for deallocating, so we have int pointer row, then int rows. Then we have int r is less than rows and plus plus. Then delete r. Then for display, so pass in the world, that's fine. Then pass in the rows, we pass in the columns. So that's perfectly fine. R is equals to 0, R row. That's perfectly fine. Then we have our array of characters over there. That's perfectly fine. So yeah, this thing should be able to display function. Okay, if it's doing that, it's not. See, anyone else who can spot the error? I don't think there's an error here. Everything's fine. Everything's fine. It's inside my export scope. Everything is fine. Just, yeah, it's perfectly fine. Yeah, yeah, check it out. Just check my password. So I don't think there's anything wrong with my code, but I think this is just something to do with my laptop. Um, and yeah, you can't spot the error. So we're left with structures. So let me delete all these functions. Delete all those. Just have what for record structures because it's definitely happening there. What we have CST lib. So let's head over to structures, then we'll fix that. So with record structures, same as enumeration. So a structure is like it's a user-defined data type that groups together variables of different data types. So with a structure, you group multiple variables of different data types. So in order to define a structure, you say struct, then you give the name of the structure. So I'm gonna call it rec world. So in your record structure, you can have any number of variables of different data types. So in my record structure, I'm just gonna have some rows, and I'm gonna have some columns, and I'm gonna have a 2D array. So yeah, here you're just defining your structure. So let's say now, in order to use that, you need to declare a variable. Remember, a record structure is like you creating your own data type, but that data type stores multiple variables of different data types, stores them, like bundles them together. So here we can create a variable of rec world type. So this is rec world. So I'm gonna call it game world. Then game world. Remember, you can create multiple data types. Let me say you can be able to do this. So this is just defining what your structure looks like and what is going to contain. This you just defining your structure and the properties which is gonna have. So you can create. Then after that, you can create a variable of that data type. You can create multiple variables of that data type structure. So now if you want to access something from that, obviously you use the accessor operator, which is a dot. When someone says accessor operator, it's talking about a dot. So you're going to use an accessor operator, then you write what you want to access in that record structure. So we have rows. So I'm gonna access the rows. So I just want to display the rows inside my game world, and I also want to display columns in my game world. So obviously at the moment, my game world has the variables rows and columns, but these are not initialized. So they're just going to be initialized to some random values or to zeros. So as you can see, they just have some random values there. So obviously, if you want to to initialize this thing, you can use the accessor operator. Then let me just say this is 1, and I'm gonna say this is 2. So should be able to see 1 and 2 there. Okay. So remember, in those functions I created a function to allocate memory and to deallocate memory. In that function, you notice that we used individual variables. A 2D array was an individual variable, rows was an individual variable, and columns was an individual variables. But then with record structures, we can bundle those variables together. So if I wanted to allocate memory, instead of passing those variables individually, you can just pass the whole entire record structure. So this is like passing a bag, and in that bag you have all the necessities which you want to use. So in our allocate memory, so we want to allocate memory of our 2D array, and our 2D array is in our record structure. Let me change this to grid. So let's say you want to allocate memory for our grid, which is inside our record structure. So we're gonna say world.grid. World.grid is equals to new int pointer. Then the size is going to be world dot rows. Okay. And we're going to loop through our array of pointers. So int r is equals to 0, r is less than rows inside our construction. So access inside construction is going to be then each pointer in our record. So it's going to be grid r is equals to yeah. Also going to define the functions to deallocate. So to deallocate memory, I only need I have some. Then I'm display and read the code. So it is equals to the uh, uh, C, 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 C. So so this way to okay plus I know what caused that error. It's because we were not passing by reference. We were not passing by reference. So we have to pass these things by reference. Oh. So that time when we had that error is because we're not passing our things by reference. So okay, you see here I'm saying allocate. So let me make an example. Let me create a function to initialize my, I'm gonna call it init, to initialize my record structure. I'm gonna call it world. So yeah, I'm not gonna pass it by reference. Then I'm gonna also pass rows. Then I'm gonna pass columns. Yeah, how did I miss that one? So world dot rows, we're gonna set it to this one. So rows, then world dot calls. Okay. Then yeah, let me cancel out this line of code with this. Okay, let me cancel out this. Then I'm gonna call my init function. I'm gonna call this function. I'm gonna pass my game world. So remember, rows and columns are equals to 20. I'm passing them via the command line here, equals to 20. But then you notice that I don't pass my record structure by, I'm not passing it by reference. So if I run this now, I was expecting my record structure to have values of 20, 20, but then they are not. I passed my record structure to my world function, but I did not pass it by reference. So remember, I'm passing it by value. If you're passing by value, then you make changes to these variables. These variables won't the changes won't be permanent after the function. So in order for the changes to be permanent, you need to pass it by reference. So now we're passing our record structure by reference. So if I run my code now, you will see my rows and my columns will be now 20. So that was the error about, because I was displaying something that was not. I called the allocate memory function. Then I thought that allocation would be made. Allocation would be made, but then the allocation was not being done on the original 2D array. So that was the error. That was where the error was coming from. So anyway, so I'm gonna call my allocate memory function here, and I'm just gonna pass my game world, and I'm gonna call my display function. And this is my display function. Display function, then I'm gonna pass my game world. Then at the end, I'm going to deallocate. Sorry. Okay, then I'm gonna pass my game. So if we run this now, we should be able to see. As you can see. So these are just random here. These are just random values because we didn't initialize the finish. So yeah, the error that last time was because we didn't pass our array, our 2D array as by reference. We didn't pass them by reference if the error was not placing the characters in the namespace. So yeah, yeah, that was the error. So let me copy out this thing. So I'm gonna go back to that code. I'm gonna undo, and so we're gonna change those functions and we're gonna pass those things by reference so that you can see. that was indeed the error. So yeah, deallocate. Yeah, so I'm gonna pass these things by reference. See. Yeah. So let me compile this code and check. Let's check. Okay, there's still something there. So we're calling allocate, display, and deallocate. Then in our allocate, we pass by reference, and in our deallocate, we pass by reference. Then in our display, we pass by reference. That should work. Let me check in my allocate memory. Let me allocate. Let me initialize everything to zeros. That was not the error. It means something else was the error. Borrowed at R at C is equals to 0. Then this if this doesn't run, I don't know what was the error about now. Yeah, as you can see. So the problem was that I did not pass by reference. So that's a lesson learned. So you need to pass by reference. I don't know how I missed that one. So embarrassing. So yeah, so ladies and gents, that's records. I think that's all for our session today. We covered everything. So from record structures. So yeah, that's everything. So that was the error. I'm so sorry for that. I don't know how I missed it. So yeah, so that's all for today. And we did cover the 2D arrays, record structures, enumerations, command line arguments, and modular programming and namespaces as well. Is there any question before we close? Any question about record structures? Because we just did them just now. So the reason why I was trying to prove a point that with record structures, you don't have to pass those individual components. You don't have to pass them. You don't have to pass those variables individual. So if you are not using record structures, you see you will be passing the 2D array, the rows and the columns, but then you don't have to do that. You can just create a structure and put everything in your structure. Then in your functions, you just pass the whole structure, which will come with all those variables which you want to work with, the rows, the columns, everything about your record structure. So that was the point that I was trying to prove. That's why I started with those functions. I was trying to make that point. So yeah, is there any question on record structures? And let me have to. Any question? Okay, So if there is no question, I'm gonna end the recording here, then the session will end here. It went over time. So I'm gonna end the recording here. Then I'm going to meet in our next session tomorrow. So yeah, that was the